One, we have an object launched at an initial speed 30 meter per second at an angle 60 degree above the horizontal. So these objects are going to perform projectile motions and then land at the same level. So in order to solve the questions, we need to break the motion into x motion and also y motions, whereby the acceleration along the x-axis is equal to 0. The acceleration along the y-axis is negative 9.81 due to gravity. And then the initial velocity, 30 meter per second, can be broken into component x and component y. Ux will be 30 cos 60 and Uy will be 30 sin 60. So we need to calculate the time taken for the object to reach maximum height. So upon reaching the maximum height, the velocity component y will equal to 0. So to calculate the time, we use kinematic equation v equal to u plus at, but we consider component y. So the velocity component y final is 0 at maximum height. Our initial velocity for component y is 30 sin 60. Our accelerations along y-axis, y directions, is negative 9.81. So we will get the time taken to reach the maximum height will be 2.65 seconds. Second questions, we want to find what is the maximum height reached by the object. So upon reaching maximum height, the final velocity at maximum height is 0. So we use v squared equal to u squared plus 2as. So the velocity component y at maximum height is 0. Our initial velocity for component y is 30 sin 60. Acceleration along component y is negative 9.81. Then we can calculate the maximum height reached by the object, whereby is 34.4 meters. Then question C, we want to find for the horizontal distance traveled by the object. So first we need to calculate the total time of flight for the object for doing the projectile motions. So the time taken for the ball to go up and then coming down is the same. Since we already calculate the time for the object to reach maximum height, so the time of flight will be the 2 times of time we reach maximum height. So times goes up equal to times goes down. So the time of flight for the object to do projectile will be 2t. 2 multiplied the time taken to reach maximum height. So the total time of flight for the projectile is 5.3 seconds. Then we will able to calculate the horizontal distance using kinematic equation. S is ut plus half at squared. Anyhow, the acceleration along x-axis is 0. So we have the initial velocity component x 30 cos 60. The time of flight for the whole projectile is 5.3. So we will get the horizontal distance for the object will be 39.5 meters. Then the last question, we need to find the time taken to reach a height of 30 meters. So now our SY is 30 meters. So we use S is ut plus half at squared. We want to determine the time whereby our displacement y is 30 meters. So our Uy will be 30 sin 60. Our AY acceleration component y is negative 9.81. So we are going to obtain a quadratic equation, solve it. We will get the time where the object reached 30 meters will be 1.7 seconds and 3.6 seconds. Maybe you're wondering why there are two answers, because the projectile will pass point 30 meters twice. First time is during the object going upwards, Another time is during the object coming downwards. So at time 1.7 second, the object will reach 30 meter as it goes up, and then at time 3.6 second, it will also reach again 30 meter when it coming downwards.